Hello everyone, welcome to my channel. I'm Ricky. Today, I will continue to share with you some lasers from this book I bought earlier. As you know, I bought this book last month. Well, I will share it with chapter by chapter, unit by unit. Yeah. And I want to make sure you will learn this book a lot. And meanwhile, to make sure I can show it more clear and perfectly. So I'm reading it deeply and with the AI to understand it. Well, through this way, to provide useful information to you. So, hope you enjoy it. So, let's get started.
Laser welding technology classification, 10 types explained simply. Laser welding is widely used in industries like automotive manufacturing, aerospace, electronics, and metal fabrication. But many people don't know that laser welding actually has many different types. In this video, I will explain 10 important laser welding technologies in a simple way. If you work in manufacturing, welding, or engineering, this knowledge will be very helpful. So part 1, basic classification. Laser welding can be classified according to different welding mechanisms. The most fundamental classification includes conduction welding, deep penetration welding. These two are the basic physical mechanisms of laser welding. Part 2, conduction welding, 2 to 330. First, let's talk about laser conduction welding. In this process, the laser power density is relatively low, typically around 10 to 10 watts per square centimeter. At this power level, the metal surface melts but does not vaporize. Heat is transferred into the material by thermal conduction, so the weld pool is relatively shallow and wide. Characteristics include smooth weld surface, low spatter, stable process. This method is often used for thin materials and precision welding. Part 3, deep penetration welding, 330 to 530. Now, let's look at laser deep penetration welding, also called keyhole welding. In this process, the laser power density is very high, usually higher than 10 watts per square centimeter. At this level, the metal surface rapidly vaporizes. The vapor pressure forms a keyhole inside the material. The laser beam can travel deep into the keyhole, which allows very deep weld penetration. Advantages include deep weld depth, narrow weld seam, high welding speed. This method is widely used in thick metal welding and industrial manufacturing. Part 4, laser hybrid welding, 530 to 7. Next is laser hybrid welding. This process combines laser welding and arc welding. For example, laser plus MIG welding, laser plus TIG welding. The laser provides deep penetration, while the arc provides filler material and gap tolerance. Advantages include higher welding speed, better gap bridging ability, improved weld quality. Hybrid welding is widely used in shipbuilding and automotive industries. Part 5. Part 5, laser field coupled welding, 7 to 830. Another advanced method is laser field coupled welding. This means the laser process is combined with external physical fields. For example, electromagnetic fields, vibration fields, ultrasonic fields. These external fields can improve melt pool stability, enhance laser absorption, reduce welding defects. This technology is still under active research. Part 6. Laser filler wire welding, 830. Next is laser filler wire welding. Next, in this method, filler wire is added during the welding process. The filler metal helps to fill gaps, improve weld strength, control weld composition. This process is useful when the joint requires extra material or better mechanical properties. Part 7, laser powder welding. Another similar process is laser powder welding. Instead of wire, metal powder is added into the weld pool. The powder melts under the laser heat and forms the weld. Advantages include flexible material control, high deposition efficiency, good metallurgical bonding. This method is also used in laser cladding and additive manufacturing. Number part 8, dual beam laser welding, 1030 to 1130. Next, we have dual beam laser welding. This method uses two laser beams simultaneously. The two beams can work in different configurations. Parallel beams, sequential beams. One beam can preheat the material, while the second beam performs the main welding. This improves keyhole stability, weld quality, process efficiency. Now, part 9, negative pressure laser welding, 1130 to 1230. Another interesting technology is negative pressure laser welding. In this method, the welding area is placed in a low pressure environment. Lower pressure helps to reduce plasma shielding, improve laser energy absorption, increase penetration depth. This technology is especially useful for fixed section welding. Part 10, activated laser welding, 1230 to 1330. Next is activated laser welding. In this process, a special chemical flux is applied on the metal surface. The flux changes the surface tension and heat flow in a weld bead. As a result, weld penetration becomes deeper, weld quality improves. This technique is similar to activated TIG welding. Number, part 11, laser spot welding, 1330 1420. Another common method is laser spot welding. In spot welding, the laser beam does not move continuously. Instead, it creates individual welding spots. This method is widely used in electronics manufacturing, battery welding, automotive components. Conclusion. So today we introduced 10 types of laser welding technologies: conduction welding, deep penetration welding, hybrid welding, laser field coupled welding, filler wire welding, powder welding, dual beam welding, negative pressure welding, activated laser welding, laser spot welding. Each technology has its own applications and advantages. If you enjoyed this video and want to learn more about laser welding technology, please like the video and subscribe to the channel. See you in the next video.